Hello guys, welcome back to our channel. In this video, I am going to discuss about major 5 important programs. First one is count of digits in a number. Second one is reversing a number. Third one is palindrome or not. Fourth one is prime number or not. Fifth one is Armstrong or Narcissistic number or not. First one, count of digits in a number. So what is the count of digits in a number? For example, if I had taken that 946, it is a number. So how many digits are there in this number means? So ones place, tens place, 100 place. So total how many digits? 3 digits. This is the answer we have to get. So how we can do? Let us try in the program. Count of digits. So first thing we have to take a number. N equal to int of input of enter n value. So after taking the n value, that is we are entering the n number. So what we have to do? We have to count the number of digits. For counting the number of digits, I am taking a helping variable called count. So I am taking initializing with the 0. That means initially I am taking the count value as 0. Now what I am going to do is while n value greater than 0, that is whenever the n value is greater than 0, I am going to do that t equal to n percentage 10. That means first I am going to check that from the ones place onwards, because if we have the 946, we cannot go to the ninth value directly. From where we have to move? We have to move from 6. After the completion of 6, we have to move to 4. After 4, we have to move to 9. That means how we can go? By using the modulo division. For that purpose, I am doing n mod 10. So then I am going to get the answer as this 6. So 6 is going to store in the t. So I am incrementing the count. That is whenever I am getting the value, I am incrementing the count. Then after that, 6 has been completed. What does the t consist of now? 946 mod 6. Mod 10. That is 6 is going to be present in the t. Then we have completed the counting of 6. So we have to remove this 6 and we have to count this 94 only. So for that purpose, what we have to do? We have to take n equal to n floor division 10. Because if we take the normal division, it is going to give the decimal, that is the fractional part values also. So now at the end, I am printing the count of digits which is available in the count. So save this program. Now let's go for the brief explanation. Whenever I take the n value as 946, so initially count is the 0. So first it checks that 946 greater than 0. Yes, it is true. So it is going to do that. So we cannot move from the 9 onwards directly, that is from hundreds or thousands position directly. So we are moving from the ones position. So 946 mod 10. That means it is giving the 6. So whenever it is giving the 6, what we are doing? We are incrementing the count. So what is the initial count value? 0. 0 plus 1. It gives the 1. Now we have completed the 6th position. Now where we have to move? We have to move to the 9 and 4. That's why 946 floor division 10. So it gives the answer as 94. Now again 94 is going to be verified here. 94 greater than 0. Yes, it is also true. Again 94 mod 10. So it gives the answer as 4. Then again counter, initially the counter is 0. For the first iteration it turned to the 1. In the second iteration, count plus 1. What is previous count value? 1 plus 1 equal to 2. Now 94 floor division 10. It gives us the 9. Again 9 greater than 0. Yes, it is also true. Now 9 mod 10. Sorry, 9 mod 10. So it gives the answer as the 9. Now 2 plus 1, 3. Whenever the 9 floor division 10, then we are going to get the answer 0. Now 0 greater than 0. True? No. That means the count is going to hold the recent value as the 3. So when you print the count of digits, we are going to get the answer as 3. Let us run this one. Yes, count of digits is 3. If you have doubt, let us test another one. 1, 5, 2, 3, 2, 5, 6. Yes, 6 digits. So this is the count of digits in our Python programming. So next one, reverse of a number. So if I take the 1, 2, 3, I have to get the answer as the 3, 2, 1. How can we get the 3, 2, 1? So here also we cannot move from the hundreds or first starting position directly. So for that purpose, what we have to do? We have to move from the ones position. After completing the ones position, we have to move to 10. Then from there we have to move to the hundreds position. For that purpose, we have to use a logic here. So let us take into the program. Reverse of a number. So first of all, we have to take a number, int, input, enter n value. So we have taken the n value. Now initially we are doing the reverse. So reverse means initially we don't have anything. That's why I am taking it as the 0. Now we are going to take that while n greater than 0. So when the n value is greater than 0, so we have to start from the ones position onwards. So t equal to n mod 10. Obviously we are getting the last position, that is, for example, 946. We are getting the 6. So what I am doing is reverse equal to reverse into 10 plus t. So whenever we are getting the any value, that should be multiplied by the 10 and that value have to be added. Then n equal to n floor division 10. So finally print reverse is comma rev. Now let us save this one 20. Now let us do the manual introspection. So if I take the 946, so initially reverse is 0. So 946 greater than 0. True or false? It is true. So here what we are going to do? 946 mod 10. So we are going to get the answer 6. That is, we got the ones place. So in the first iteration, what is the initial reverse value? 0. 0 into 10. Nothing but 0 plus 6. So initially 6 is going to be stored in the reverse. Then 946 floor division 10. So we are going to get the 94. Again the loop will be executed. 94 greater than 0. Yes, it is true. Now 94 mod 10. So we are going to get the answer as 4. So here, look at here. Reverse into 10 plus t. What is the previous reverse value? 6. 6 into 10. That is 60 plus what is the present t value? 4. 4. That means 64 is going to be stored. Then 94 floor division 10. We are going to get as the 9. Again 9 greater than 0. Yes, it is also true. 9 mod 10. Obviously it is nothing but 9. So here, look at here. What is the previous reverse value? 64. 64 into 10. That is 640 plus what is the present t value? 9. 9. Then 9 floor division 10, that is equal to 0. 0 greater than 0. False. Now whenever we try to print the reverse value, what is the previous value we have got into the reverse? 649. So 946 reverse, isn't that the 649? Yes. So 946 reverse is 649. So if you have a doubt, let us run again with another number. 1852496. Yeah, 6942581. So this is the reverse of a number. Next, palindrome. What do you mean by palindrome? A palindrome means nothing but original number equal to the reverse of original. So if you reverse any number, then if you get the original number, then it is called as the palindrome number. For example, 121. If you reverse the 121, then also you are going to get the 121. So at that time it is called as the palindrome number. So for checking whether a number is palindrome or not, simply what you have to do, first of all you have to reverse. So I am copying this one. Again I am taking another program. So palindrome of or not. So removing this all these previous steps. Here what I am going to do is I am going to store the n value in temp also, because okay, if you take, no problem. If you don't take, nothing is going to happen. But if you won't take this, the n value is going to be changed here. That's why I am taking the temp. Now instead of printing the reverse, what I am going to do is, so the reverse of a value is going to be stored in the reverse. That n value is modified and it becomes a 0 after all the iterations which you have seen in the reverse program. Now for the purpose of this one, I am securely storing the n value in the temp also. Now temp consists of nothing but the whatever the n value. Whatever the n value. Here n value becomes 0 after all the iterations. Now if reverse, whatever the reverse value obtained is equal to temp, then simply you can say that print temp is palindrome. That is, n value is available in the temp. That's why I was saying that temp is palindrome. Next, else print temp is not a palindrome. Save this. So run the program. Now it is asking me to enter the n value 123. So when you enter the 123, reverse is going to get the 321. Temp is going to get the n, that is 123. So 321 equal to 123. It is false. So what is the temp value? 123, which is the n value. 123 is not a palindrome. Yes, 123 is not a palindrome. Again run this one. 121. So when you 121 is reversed, then also we are going to get the reverse value as the 121. 121 equal to what is the temp? Nothing but the n. So n is nothing but we have entered 121. 121 equal to 121. Yes, it is true. So temp is palindrome. 121 is palindrome. So this is palindrome or not. And next one is the most important one, that is prime number or not. If you say any number as a prime number or not, if that number is divisible by 1 and itself. If a number is divisible by 1 and itself, then that number is called as the prime number. So prime number start from 2, 3, 5, 7, 11, 13 and so on. So if you observe all the numbers which were given here, 2, 3, 5, 7, 11, 13, they are divisible only by that 1 and by themselves only. 2 is there, 2 is divisible by 1 and 2 only. 3, same, 1 and 3. 5, 1 and 5. So, if any number is having the divisors as the 1 and itself, then that number is called as the prime number. Take a proof. So, first of all, we have to take the number. So, n equal to int of input of enter n value. So, after entering the n value, first of all, what we have to do? We have to check how many divisors are there for that number. For that, I am taking the count equal to initially 0. So, for I in range of 2, n. Here I am not considering the 1 as a divisor because by default 1 is a divisor for any number. That's why I am not taking from the 1. So I am taking it from the 2 onwards up to the n. N means whatever the n value you entered, that minus 1 will be taken. That means here we are excluding the 1 and the number itself. Here we are excluding the 1 and the number itself. So if the number mod I value is equal to 0, if the number is divisible by any number, then what I am going to do is I am going to increment the count by 1 and then I am breaking, because here we have considered the 2, n. That means we have omitted the first divisor 1 and the n means if we take the n as 5, 5 means 5 minus 1, 4 will be considered in the range. That means the self divisor also excluded. For that reason, if the number is divisible by any other number rather than 1 and itself, then the increment of the count is done and then I am breaking. So now I will check. If count is not incremented, then I will print n is prime number, else print n is not a prime number. Save already exists. Now look at here. Let's do the manual introspection here. Palindrome, this one close. Yeah, I have taken the n value as 7. So initially count is 0. So I am starting it from the 2, 7. 2, 7 means the values will be 2, 3, 4, 5, 6. That means I am not going to divide the n value by the 1 and also with the 7. So that means I have excluded the 1 and the self divisor. That's why I have done that. I am verifying whether the number is divisible by any other number. 7 mod 2, it is not possible of the 0. 7 mod 3, not possible of 0. 7 mod 4, not possible of 0. 7 mod 5, not possible of 0. 7 mod 6, not possible of 0. So the count is not going to be changed. That means 7 is prime number. Sorry. 7 is prime number. Now, if you consider this one as the 6. Now, 2, 6 means it will take up to the 2, 3, 4, 5. Here the first step is, what is the n value? 6. 6 mod 2 equal to 0. Yes, 6 mod 2 is nothing but remainder as the 0. 0 equal to 0. True. Whenever a number is divisible by other number rather than 1 and itself, then we are doing that count equal to 1. Count equal to 1. Whenever the count equal to 1 has happened, break. So the count value is 1. 1 equal to 0? No. So it prints that n is not a prime number. 6. 6 is not a prime number. This is the simple program to check whether a number is prime or not. And the last one is the Armstrong number or Narcissistic number or not. what is this Armstrong number? So most of the people will confuse you with as the sum of the cubes of the numbers, but it is wrong. What is this Armstrong number mean? If you consider any n digit number, whatever it might be the n digit number, so that is the sum of the nth powers of its digits. Sum of the nth powers of its digits. For example, if you are consider the 145, so you have to take it as the total how many digits? 3 digits. So 1 cube plus 4 cube plus 5 cube. This means sum of nth digits, nth powers of its digits. Sorry, sum of nth powers of its digits. So what is the power value should be taken? The number of digits should be taken as the power. So for example, if you take the Armstrong number, another number 1546, that means it is not the sum of cubes, it is sum of the nth powers of its digits. So our total how many digits? 4 digits. That's why 1 power 4 plus 5 power 4 plus 4 power 4 plus 6 power 4. So this is the original Armstrong definition. If you take the 5 digits, then sum of the power as the 5 value. Let's look into the program. So Armstrong or not. So first of all, take a number, enter n value. So after that, I am going to take this n value into the some other stories, because here what we have to do, first of all we have to count the number of digits, because those number of digits are going to be useful for finding out the powers, sum of the nth powers. That's why first of all we have to take the count. For checking the count, I am taking count equal to 0, and then for temp value as n, again temp 2 equal to n. So why we have taken temp? So to find the number of digits in a number, I am going to use the temp instead of n. To find the sum of the nth powers of the digits, I am going to use the temp 2 instead of n, because this n is going to be useful later. I will tell you. So I have taken this stuff. So temp 2 equal to n, temp equal to n. While, so here what we are doing? Counting digits. While temp greater than 0, because temp is nothing but n value. So we are going to do that d equal to n mod 10. So first of all we are finding the digit, then I am going to do that count equal to count plus 1. So I have found the count also, temp equal to temp floor division 10. So finally we are going to get the count into the count 1 variable. Next, after finding the count, what we have to do? We have to find the sum of nth powers of its digits. Oh shit. So while now I am going to use the temp 2 greater than 0, because why I am not disturbing the n means, after getting the sum value we have to compare with the n value. That's why I am not disturbing. So I am going to take the t as it, that is for each and every digit I have to calculate temp 2 mod 10. That is first last digit will be calculated. Then what we have to do? Sum equal to sum plus, that is we have to add the each and every digits with the nth power. So what is the base value which is available in the t? So t exponent count. Count is nothing but the number of digits. Then I am going to do the temp 2 equal to temp 2 floor division 10. So finally, yeah, before going to do that, sum equal to 0 I am going to take. So initially sum value will be 0. Finally the result is going to store in the sum. Now we have to check if sum is equal to number. Then print n is Armstrong number. Else print n is not Armstrong. Let us do the manual introspection. So first we are going to take the n value as 1634. So initially sum 0, count 0. Temp value is none other than n, that is 1634. Temp 2 is also 1634. So first we are going to do that 1634 greater than 0. Yes. Then each and every digit 1634 mod 10. So we are going to get the 163. Then count equal to 0 plus 1 equal to 1. Then 1634 followed division 10, that is equal to, here this is 4. Here 163. Then 163 greater than 0. Then here 163 mod 10 equal to 3. Then 1 plus 1 equal to 2. Then 163 by 10, 16. Like this it will be continued, and we are going to get the count value as the 2 plus 1 equal to 3. Then 3 plus 1 equal to 4, because 1634. Now temp 2. So we know that temp 2 is also 1634 greater than 0, true. Again 1634 mod 10 equal to 4. So initially sum value is 0 plus, what is the t value? 4. 4 to the power of, what is the count? 4. That is, here what is the Armstrong definition? Sum of nth powers of its digits. 4 is a digit of the 1634? Yes. So we are doing that and we are adding it to the sum. So 4 to the power of 4. 4 4 16, 16 4 64, 64 4 256. 256. Then 1634 flow division 10 equal to 163. Like this the loop will be iterated. So the last value is going to store into the sum. So in the next one 163. 163 means here 3. Here 256 plus 3 power 4. Like this it is going to be added. Now lastly the sum value is going to hold the sum value after performing all the operations. Now it is going to compare with the n. Because I haven't disturbed n value. Because we have taken the temp 2 and we haven't disturbed n. So if we check both the values are same, then we can say it as an Armstrong number. Now run the program. 145. Yes, it is not Armstrong. Good. 1634. Yes, 1634 is an Armstrong number. 153. 153 is also Armstrong number. So another one. 375. Not Armstrong. 370. 370 is an Armstrong number. So these are the different programs and important ones in the loops concept. Thank you. Please like, share and subscribe to our channel LifeLiyo. Thank you everyone.